Hello! Today, I would like to take the time to introduce VEX Code VR, which is an online format of CS coding created by VEX. It is mainly drag and drop, which makes it perfect for beginner coders, but is also composed of difficult challenges that require algorithms. No matter your skill level, VEX Code VR is for everyone, and today we will be learning the basics. To access VEX Code VR, you're going to want to type in vr.vex.com into your search field. Once it's loaded, you'll see that we have many interesting things on our workspace and toolbar. Our toolbar is on the left-hand side of our screen, and it will be where we get all the code to test on our robot. You'll see that we have a workspace on the right with a when started block on the top. Basically, all the code underneath this will happen when you click the start button. Well, where's the start button? Go ahead and click on the playground button on the top right corner of your screen. On the center of your screen, you'll see a big yellow floating box that says grid map on the top of your playground and loading playground on the center. This will be where we can test our pre-built VEX Code VR robot. It has many interesting features, such as 2 ultrasonic sensors that can detect distance, color, and if there's an object there. We also have 2 bumper sensors which can detect if something hits the robot. We also have a gyro sensor which can detect the direction and location of our robot on the field at any time. Finally, we have a pen and magnet. The pen can draw on our field as the robot moves, and the magnet can interact with discs on the robot. We aren't, however, going to use the grid map. We're going to switch this to the number grid map. Go ahead and click on the white bar above the Select Playground button and click Number Grid Map. Once you click it, your playground should reload, and if you're on an iPad or mobile device, it should reload the page, and this is what you should see. It's just like the grid, except it has numbers. This will be helpful when I give some directions on where to go and what squares. So what we're going to do first is let's drag this playground to the right of our screen so we have a bit more space. Now let's look at some of the first components of the toolbar. To make our robot drive forward, we would want to use the drive forward command. However, we usually don't use the drive forward without any distance, as it does it indefinitely. So we want to control how much distance we want our robot to move. So go ahead and click on the drive forward for 200mm block and drag it over to the workspace. Then simply drag it under the when started block and you'll hear a click. That click indicates that the code has been attached, so when you click the start button, the robot will move forward. Just as a rule of guidance, each square is 200mm apart. So no matter which direction you move, other than diagonally, you will have to move 200mm to get to the next square. If we run the code, you can see that we reach the number 11, or 1 square forward. Now, if we want to turn right, we can click the turn right block. But same as the drive forward, we're not going to use just turn right, as that it will do it continuously. It will spin in circles until we stop the code. What we're going to do is we're going to drag a turn right for 90 degrees over from the toolbar and drag it under the drive forward. You should hear a click, and then the robot should turn right. So click on the reset button and then play. The robot should go to the number 11, but then it turns right. You can see that there's a 90 degrees icon here. 90 degrees is usually how much we want to turn, either right or left. If we want to turn back, it would be 180 degrees. But usually you only use 0, 90, or 180 degrees when you want to turn your robot. Let's take a look at the other components we have. Before we look at them, you can see that there's an arrow here under drive forward and turn right. If you see, turn right can change to turn left, so this block is customizable. For drive forward, we can also change it to drive reverse if we want to go backwards. And this distance in here is also changeable. We can type in a new number, and we can also type in a new degree. Now, what about these things? So first of all, you might have noticed that our robot moves really slow on the field. Well, to change that, we need to change our drive velocity speed. Currently, it's set to 50%, but to make it go faster, we should do 100%. So move these under the when started block. It has to be at the very beginning for it to have effect. We can change the 50 to 100, and now you can see that our robot moves faster this time. Finally, let's look at turn to heading, turn to rotation, and stop driving. Turn to heading means to the right is 90 degrees, Behind you is 180, to the left is 270, and forward is 360 or 0. Usually 0, 360 if you want to spin in a full circle. But the rotation, however, if you turn right, then turn right, and turn right, you'll be back to the center, or 360 degrees. Turn a heading would say that you are at 0 degrees north. But the rotation would say 360, and if you turn right again, it would add 90 again. So turning right adds 90 degrees to the rotation, turning left subtracts 90 degrees from the rotation. The heading just stays the same no matter how many times you moved before. And finally, stop driving, as the name suggests, stops the robot from driving. It usually is placed at the end of code, but once the code ends, the robot automatically stops. So that's why we don't usually mess with rotation. We usually use heading or regular turns. And the set drive heading and set drive rotation usually don't have much benefit, as if you turn right and then set the drive heading to 0, it will erase the 90 degrees and say north is now going east, if that makes sense. 0 degrees would become 270 degrees and 90 would become 0. Now it's time for a challenge. What I want you to do is I want you to erase your current code, and I want you to make your robot go to the number 35. Use all the code that we've learned so far, or anything that you might know so far. Go ahead and pause the video now. Remember to set your drive and turn velocity to 100%, and remember to use all the code that we learned so far. Pause the video here to try it out for yourself. Okay, I hope you've given the challenge a go for yourself. Let's do it together. We need to go to the line of the 30s, which is 31, 32, and so on. That's 1 square forward, 2 squares forward, 3 squares forward. That would be 600 millimeters because each square is 200 millimeters, and we need to do that 3 times forward, which is 600 millimeters. So let's drag a drive forward for 200 millimeters and change it to 600 millimeters. Now let's do a turn right for 90 degrees, or if you're feeling fancy, go ahead and do a turn to heading 90 degrees. Now let's do a drive forward, another one, because we need to go forward 1 squares, 2 squares, 3 squares, 4 squares. That would be 800 millimeters, or 200 times 4, because we need to go forward 4 squares. If you run the code, you'll see that we reach the number 35 as the challenge directed. Good job! If you had an error in your code, then maybe you made a mistake in your turns, but if you didn't, congratulations, you successfully solved the challenge. Let's try using a few new features that might be a little advanced for some, but let's try to do it nonetheless. Go ahead and switch the playground to Disk Mover. You can do this the same way by clicking on the white bar and then selecting Disk Mover. Now we're going to use the built-in pen. Click on the Looks button on the toolbar and you'll see a list of commands for the pen. This also works with print, which I'll explain in another video. Go ahead and drag the Move Robot Pen down and add it under the turn velocity. You can also change the color by adding another block that says Set Robot Pen to Color, and then I'll change it to blue since we're going to be working with the blue column right now. Now what we're going to do is we're going to integrate the Control, Sensing, Operator, and Variables menu to try to get one of these blue disks back to the blue goal. Go ahead and drag a repeat until loop from the Control menu and add it under the robot pen. Basically, the control section repeats something or does something if a condition is satisfied or if a condition is not satisfied. Basically, the repeat 10, forever, repeat until, while, wait until, all of these basically do something until something happens or wait until something happens. What we're going to do is we're going to get a drivetrain from the drivetrain menu, get a drive forward for 200 millimeters, but not this time. Get a drive forward indefinitely. This will be helpful for getting to the blue disk, and I'll explain why later. Now what we're going to do is we're going to go to the magnet section. These disks can be manipulated or moved using the magnet that's built into the robot. Go ahead and drag Energize Magnet to boost and add it under the drive forward command, but still inside the loop. Now we need to have a condition that's going to go in this hexagon shaped gap. Go ahead and go to the Sensing menu and add the and find the when front down eye is near object. Yours might say front eye, but it's the same thing. Go ahead and add it in the hexagon-shaped gap. This will keep going forward until an object is detected by the ultrasonic sensor that faces downwards. Now what we're going to do is once we picked it up, so this code basically picks up the first blue disk. Now what we're going to do is go back to the goal. We need to go to the drivetrain and get a drive forward for 200 millimeters. We're going to add an operator and we're going to put it inside the distance area. This will allow us, and operators basically are things that you can do with a calculator or equations. You can see that if something is greater than a number, less than a number, equal to, or sum, division, multiplication, subtraction, or addition. I'll cover the rest of these in another video as they're a bit advanced. So now we're going to fill in one of this with 500. We can also add 200 here because if you can see this is 200, 200, 200, 100, which is 700. So which would be 500 plus 200 to return back to the goal. But let's add a variable. Variables basically store info, and the info can be changed later. Go ahead and get a set my variable to 0 and add that to the very top of the code. Change the 0 to 200 and the value that's now stored in my variable is 200. Go ahead and drag the my variable from the top left corner and add it into the blank spot in the operator. This will add 200 plus 500, which is 700. Oh no, I forgot. We're driving reverse, so this has to change to reverse. Now we need to drop the magnet. So go ahead and get the energized magnet to boost, but instead of boosting, we're going to drop it. If you run the code, you'll see that the blue disk is picked up. One thing to mention here is that if we would have run the code and this would have said forward, and we would have realized that our code doesn't work, we would have been debugging. Debugging basically looks through the entire code, and if it doesn't work, we have to find what went wrong and change it. That's debugging. So you can see here that our pen drew to the disk, picked it up, and came back. Our mission is successful, and we've picked up a blue disk. And that's it. Thank you for taking the time to watch this beginner's tutorial about VEX Code VR. I hope you've learned lots about VEX Code VR and that you'll decide to continue learning about coding in the future. For beginners, thank you for trying to learn coding. VEX Code VR is a really good place to start. Thank you for watching this tutorial. Have a good rest of your day.